yeah, 4, 5, yeah. So this is hard, right? So you can put 2, yeah. No, I put 4, yeah. Oh, I put there 3, 5, right? Yeah. So we will use the technique called album method to determine how many clusters we should divide. Okay? So idea, right? You can put a 3 group, 5 group, yeah? We cluster them together. And once you say how many 3 group, red, blue, this one, yeah? Then you use century. Yeah? You decide the century. Decide the century. Yeah? The century is mean like a capital city in your country. What's capital city for Canada? Ottawa. Everybody visit Ottawa? Yeah, Ottawa. Where's Ottawa located?
Near Toronto, right?
Between Toronto, the half in Ontario, half in Quebec, yeah, the political city. So that's assumed century for Canada. The reason for that, most of the population located in Ontario, Quebec, and also are Canadian fight each other, yeah? Right? Put in the middle, right? And also for political reason, right? So you have your representative come to central, right? Right? Make decision. Every weekend, easy for them to fly back to home. Otherwise, you put a capital city in BC, right? Take 6 hours fly back to Newfoundland, right? More than 6 hours, yeah. That's not good. When you put it in the middle, right? You able to convenient, right? So just assume that's kind of center, which is nearby everybody, yeah. So once you determine how many clusters, what's central for the cluster, then you easily make prediction, right? For example, I got the new guys there, yeah? Tell me what's your hometown? Oh, magnitude, longitude. So I will measure you to this cluster, or this cluster, or this cluster, which is nearest to. Yeah, oh, you are close to the Indian cluster. Okay, I divide you to this cluster, right? It's prediction, yeah? Once you determine this, how many clusters, how many centers, right? Are able to calculate which cluster you belong to, right? Okay? So there's a concept of centroid is a central of your cluster. Okay? So this algorithm, K-mean algorithm, is basically figure out, yeah? So how many clusters, what's your century? And this show you the algorithm learning can eventually set it up. What's optimized cluster you belong to, right? So this is the algorithm doing, yeah? So this one, eventually divided by 3 clusters, yeah? So K, how many clusters, yeah? Mean is equivalence distance function. Okay, so this is critical right now. And how many clusters divide your data set? So that is called elbow. So idea, so this is a K number, and this is a utility. Yeah. So basically, if you divide, it's one group, right? And so there's some of you live in the BC, some of you live in Newfoundland, some of you live in Ontario, right? The total function is huge, yeah, right? Okay, so I'm going to reduce this one. Now I divide by 2, which will reduce the total function. Now, right, I divide it. You guys say the majority of you from India, other Far East, then you have then I'll put you, I don't know, Brazil, where you put it, right? It's still huge distance for 2, right? Say I put you in China, Far East group, right? Still a long way, yeah? Now I want to divide by 3 clusters. Right? One is India, one is Far East, China, Taiwan, Japan, Korea. One is Brazil, South America, yeah, including Mexico, right? So the total distance function each other will be reduced further, right? Yeah, but you cannot divide by each person, each group, right? Then you get more, distance together. Remember? Yeah, each person of a group, right? So that's an optimized concept. So what is the optimized group? Depends on this elbow program. Yeah. So this elbow, where's the point? To give you optimized group, right? Can you divide this elbow? Which group they belong to? How many groups you can divide this dataset? Yeah. Some people say this 2 because the elbow point 2. Some people say 3. To me, it looks like 3. It's more sharp, right? More elbow. So this determines k equals 3. Yeah. So for you project, yeah, you need to show me your elbow diagram. Then you determine the k, how many clusters you divide. Yeah. Okay. So there's a lot of package have it. Today I'm showing you Python. You can use the Excel. Yeah. You can use the Tableau also can do that too. Yeah. You can do this elbow. A lot of application for this kind of k-mean method. For example, every 5 years, every year, right? That's like the best whiskey in the world. So you might all this export to taste. That will tell you where is whiskey, right? So you will test the whiskey, and depend on the color, nose, the body, the plate, right? Then see which category of the whiskey. Yeah? Then in this category, what's best whiskey, right? Oh my God, we this category whiskey, yeah? This is blind tasting, yeah? Yeah? So this is an example of the k-mean method, clustering method, yeah? Basically, pure blind doesn't tell you anything. You divide by which group, right? And which is best whiskey you select, yeah? Today I'm going to give you an interesting clustering demo for flower classification. Anybody use this kind of application, right? You put an application there, then you see that's beautiful flowers. Okay, you just take picture of flowers, and you think, oh, this is flowers. Have you used, anybody use this kind of flower? Yeah? You use it, what's the app, the name of this app? Yeah? Okay.
Something like Pano.
Yeah, so this is application. That's good. Now tell me. Yeah? So this kind of app is powerful, right? Just take a picture and take flowers. How to maintain it? Oh, then over water. Yeah? You put at least 2 hours sun per day. Yeah? That's kind of carry information, right? So this is the application we are going to develop. So what we are going to do, we have a famous called iris flower. This iris flower. Yeah? And experts say this flower can divide by 3 kinds. One is a vertical, which is a big leaf. Yeah? One is a virginica. One is the center. Right? But the center looks very similar, right? But experts say this is totally different species, right? And so how to identify the flowers? Right? The experts say it depends on this, sample pattern. To me, it's a big leaves. This is length, this is width. Small leaves, this is length, width. Yeah. And based on the 4 variables, you can divide the flowers to 3 species. Which species they belong to? Yeah, without any knowledge. Is that interesting? Take picture. Oh, this is center. Take a picture. This flower. Okay? Yeah. So we will do this exercise to use the k-mean method, right? So I use the Python. So the dataset, you can search for dataset everywhere, right? So the dataset is very famous for statistics, right? 150 rows. And they have 150 row and 5 columns. And the last one give you the class label. We assume we do this one, right? Yeah. We only use this full column to identify which flower it is, right? Yeah. So we can download this as this data, this table, but we only use this full column. Then you class to which flower it belongs to. So I give you demo Python, which is it's optional for this course, yeah, and very powerful AI language. Yeah, if you know Python, you can easily make big money here. You don't have to do MBA. Yeah. If you know Python very well, you can get $200,000 per year in Silicon Valley. But it's a very interesting language. The first one is easy to learn. I will show you how easy it is. The second one is open source language, Python language. What do you mean by open source to you? Open source, what do you mean open source? Yeah, it's free. You can download on your computer, right? Everyone can download. And more importantly, because it's free, it's open source, everybody love free this stuff, but also help you out. The people look like church people, yeah? So you always get help when you ask something, yeah? And it's a high-level language. They can run it on your Mac, running on the Windows, running on your phone. It's nice, yeah? Okay? And this is introduction. So how easy? This is two textbooks in kindergarten in China. Anybody know Chinese? Yeah? Yes. So how do you read that one? The first textbook. Yeah?
人工智能.
Yeah. So this one you say, what does it say? You can play Python. Yeah, you can learn, right? This is a kindergarten, the textbook. Start from, that's why China is leading in the AI area, right? America is very free. They learn earlier. This is also, AI. You also learn Python. Even you don't want to become, business analyst, data analyst, right? You can teach your children. Yeah? Particularly right now, very hot for Chat GPT, right? Chat GPT. Yeah? The public language most likely is Python language, reading the code. So computer language, right? Like any language, yeah? We humans speak high-level language, yeah? Do that, right? And English, for example, right? And computer is stupid, right? As we said, computer only know 0, 1, 0, 1, yeah? It's machine language. So any language that functions as a translator, interpreter, is translate high-level human language to machine language. So that's why you should have some editor, yeah? And the good things for the language inventor and also the community already build a lot of function there. For example, this k-mean algorithm, right? You don't have to, do the low-level k-mean doing work, right? They already build the function for you. You just use it, yeah? And they put it in a library called Python library. You just import the library first, yeah? Then you read your dataset, the iris dataset. Then typically you're doing visualize your dataset. How many what kind of histogram, summary statistics, right? All this basic stuff, yeah? You need descriptive analysis, yeah? Then you're doing more inferential analysis, yeah? Doing prediction, doing clustering, doing logistic regression, yeah? So this is basic steps. Load library, reading data, plotting data, doing summary statistics, then doing more advanced work, yeah? Different algorithm. So that's a library. It's very important because for you, computer nowadays huge memory. Just import all the library. For Python library, you have a NumPy, SciPy, numerical pi, SciPy scientific calculation like equivalence function, right? Then you have a Panda, you have this visualization function, yeah, and Python have a very advanced visualization function there. But you need some learn in order to use it, right? That's why I use the Tableau. Is much easier for you, right? The drop, draw, right? This is why I need a coding. Okay, so we use 6 steps to do this work. Use the k-mean to cluster the iris flowers. So number 1, you install the Python, and then you load Dataset. This Dataset is not in your hard drive, in the website. You just read it from other website. Okay? Then you summarize this Dataset. Then you visualize this Dataset, right? Then you train called fit the k-mean algorithm. Then you do predictions, right? So after training, you say, oh, what is flowers? Just take a look. You take a picture about identify big leaf length, big leaf, short leaf width, right? For the four variable. Then oh, this is what's flower? That's the tail, right? That's why your app's tail, yeah. Okay. So basically, the result looks like that, yeah. This is the code, yeah. It's a high level language, yeah. Read, visualize, plot, yeah. And then you get this kind of output. So, from a k-mean algorithm, they divide by 3 groups. Blue, red, and the green, which is the central, red is central, and blue is a vernicolor, and green is a virginica. Yeah. Then, if common people, not expert, right, it will be divided by 2 groups, right? But for expert settings, it's totally different group. Maybe the found flowers, yeah, originally from Africa. This flower found in China, right? It's totally different environment. I put a separate name for this color, red color. So the important is you need this elbow, right? You need to build an elbow. So you can use Excel, but it needs a lot of work. But you can use Excel package called Excel Statistics. They have a lot of function because my previous class used this package. However, it's costing you $1,000. License fee, right? Forget it? Yeah, no, it doesn't work. But it's fine. You don't want to pay. The company knows your sensitivity. They give you 2 weeks free trial, like a Tableau, yeah? You can free trial. So if you have 5 people team, right? Make sure 2 of you or 1 of you download first to try. This one lasts for your last week. Yeah, you still have something to demo. As a way to deal with it. Yeah, my stuff is expired. I cannot show anything. Yeah, this is a very good package. We have a video there. Show you. Very good package, complete package. Of course, any good things you have to pay. Well, you don't pay, ask your boss pay. Future employer pay. Okay, let me give you a demo of Python. Okay. So the Python, that's a mini editor for Python. Okay. So one of this good one, which I love to use, called encoder. Encoder is big slave, right? Encoder. So this package have a lot of other package, machine learning package, right? Yeah, like IBM things, yeah. But we use editor called Spider. You can use other Spider, web-based Spider. Editor. You can use Python editor. You can use the Google editor. You can use that one, right? So I use this editor called Spider. Okay. Yeah. So I open up the Spider. It's kind of editor, right? Basically, you write program there, like your Microsoft Word, same thing. So the source code already in your course portal. You can play around, right? Yeah. For your children, you should apply it. You should practice. So this is a program which I borrowed from somebody else, right? Because open source, I don't tell you where it comes from, yeah? And I improve it. I add some my parts there, yeah, for this problem to solve, right? So most of the programmer, very few genius programmers who write some code from by themselves. They always copy the other people's code, then improve it. Okay? So I did the same thing. So the sixth step, right? The step one, basically import all this library, yeah, and the Python library. So this is written in the Python. You can. So let's pay attention, right? So step one, you import all the library. Okay. The reason for simple, right? The children nugget, right? You can do this kind of calculation. Yeah. Time. Is that interesting? All right. And most programmer want to write first programmer print.
So try to do it in Excel.
Hello. Word. Yeah. This means first program done. Okay. So this is called interpret the model. This is a program, right? It's running a code, running, batch the model. So let's run this program. You just highlight. If you run the program totally, right? You click there, all okay. But I'm running segment by segment, right? I'm running just this highlight one. So this is import all the library there, yeah. The step two, I want to read this dataset from there, from this URL, yeah. So this is step two, read dataset, right? From this URL, iris flower dataset. So there's an error, that's fine. Error no issue for programmer, right? Always have an error, you debug. Now the dataset is really in my memory. How to do that? You can see, you can type. You can type dataset, because I read the dataset, put the name of the dataset, right? And we do it. Step one. We open it. Okay, so why? Because I erased some of the code. We do that again.
Professor?
Yeah.
Does Excel have any provisions to determine how to segregate the data in number of clusters by
Excel? Yeah, Excel can do it, but you have to do a lot of work. And use Excel statistics, yeah, the package Excel. That's running on Excel. And so I already just rerun this code. Then this should be in the dataset. So this dataset really ready, right? So they tell you total 150 row, 5 columns. 1, 2, 3, 4. We assume we didn't lose this column, yeah, because it's unsupervised learning. Then you do some summary statistics, yeah, about your data. Very simple one. This code can tell you about your data set. Okay, so this summary statistics are about the mean, the standard deviation. What's the maximum? What's the minimum, right? So that will tell you 4 variables there, and for the big difference, count 150 row. The mean 5.84 centimeters, and the small is some less, right? And this one less. Then what's state deviation, right? This summary statistics, yeah? Give you an idea about your data set. After that, you're doing visualization, right? There are many tools you can use the Python. For example, you can run this code, and then import all this code. The histogram. Most popular is histogram, yeah. The box with a diagram. This box wizard, yeah, about this outlier. This one histogram, right? Yeah, you can see this is 4 variable distribution. The big leaf will look like a normal, right? The small leaf is different kind, yeah, right? So the small leaf, different shape. What kind of flower? Yeah, probably have unique features. So after that. For you guys, for our analysis, the scatter diagram is very important. To plot you in a X and a Y, the scatter diagram look like that. Then after that, you do some of the visualization. Okay, now we get to a very important called elbow method to see this elbow. So this code you can reuse. If you try Python, yeah, you can reuse this code, yeah, fit your data set, okay? So this one will produce your elbow. See, elbow on your data set, right? So this is a cluster, this is a utility. From elbow, so which elbow you point to? Yeah? Some people argue 2, some people on 3. Yeah? But expert said 3. So that's why you use 3. But you could argue it's 2, right? An elbow. Then once you decide it's 3, then you fit this algorithm. Right? You can see, right? Plus equals 3. K equals 3. The K equals 3. Then you train your model. Then you're doing visualize the training result, which is this code. Right? So tell you this 3 cluster, the data set, right? All your data set, 150 data set, right? The blue color, red color, and the green color, different flower. Right? So they can see, oh, this is center. This is Virginica, right? This is make prediction. So the K-learning, algorithm behind that is a simple equivalence distance function. And how to determine how many clusters, you need the optimization part. And so you use elbow diagram. Yeah? Once you decide how many clusters, that's easy, yeah? You are India, you are Far East, you are Brazil, right? Then let's see what is central of your data set. Yeah? Visually, right? Some of the equal distance to the central, right? It's called central. Once you know central, right? Any new data set, I can make prediction. Yeah? Any new guy like me, I measure distance to you, I make it to you, and